To begin our discussion, let's first talk about what double angle identities are. Double angles are a collection of trigonometric identities for angles of the form 2 theta. These identities can be demonstrated using the sum of angles identities. When considering double angle tangent explicitly, we must know the basic form of the sine and cosine, because these are the integrals when tackling tangent.
The basic forms are as follows. Firstly, is we have is sine. The standard identity is 2 sine A cos A. Up next is cosine with 1 minus 2 squared A. And finally, for the focus of our discussion today, the tangent which has the standard form of 2 tangent A over 1 minus tangent squared A. When using the formula with given theta, you will just need to substitute the given sine and tangent theta to the actual formula, but when solving with the tangent given, it would be a lot more difficult. So let's start solving.
Hi, my name is Cyryll, and I'm going to be going over the step-by-step process to solving double angle tangent. So for our first step, we're going to have to remember the given formula for double angle tangent. So that given formula, or that formula for double angle tangent, is 2 tangent A over 1 minus tangent squared A. So that's going to be our formula for this entire process. Now, keep that in mind. As for our second step is all about identifying the given. So to identify the given is about as simple as it sounds. You just have to find if sine theta or cosine theta or even tangent theta is given. Now it's a bit situational because if tangent theta is given, then you're going to have to go to step 4, which I'm going to explain in just a bit. However, if you have sine theta and cosine theta as your given, then just use the formula tangent theta is equal to sine theta over cosine theta. Now for step 4, which is using the quadrant to assign the proper sign to tangent theta. Now what I mean by signs here is positive and negative signs. So properly assign the right sign to tangent theta by using the signs of sine theta and cosine theta. So yeah. Now as for step 5, solving it, simplifying the necessary parts of the formula once all the necessary values are actually acquired. And for our last step, simplifying the fraction. So simplifying the fraction is simplifying the fraction. If your final answer is a fraction, see to it that it is in lowest term. A good example of this would be 3 over 6 as your final answer, and then you lowest term that to 1/2. And that's the step-by-step process to solving double angle tangent. Thank you so much.
Now that we know the tan double angle identity, we can now use it to solve problems. So for our first example, we will be solving with a given tan theta square root of 5 over 3, and we will need to find simple lang muna tayo. So we will need to find tan 2 theta. So yan yung kailangan natin hanapin. So since this is just a simple problem and we already have tan as a given, we don't have to do anything to it. We just have to substitute it to our given identity for tan 2 theta. So now, let's substitute it. So our problem will be tan 2 theta is equal to 2, the value of tan theta, which is square root of 5 over 3 rather, all over 1 minus tan squared theta, which is this, but only squared. There. Now, let's simplify it. So, it will be 2 times square root of 5 over 3, which will be 2 square root of 5 all over 3 over 1 minus the square root of 5, or square root of 5 over 3, which will be 1 minus 5 over 9. Since it's already squared, we can just minus it. So let's move over here, above up, and we simplify the denominator since we can minus them. That will be 2 square root of 5 over 3 all over will be 4 over 9. Since we minused 1, 2, 5 over 9. So now, let's simplify the whole fraction. Since it's division, we just have to multiply it. It will be 2 square root of 5 over 3. Reciprocal of 4 over 9 will be 9 over 4, which in turn will give us 18 square root of 5 all over 12. Simplify these two. Our final answer will be 3 square root of 5 all over 2. That will be the value of tan 2 theta. See? Simple, right? For our next example, it will be a bit more difficult than the first one, since our given will be cosine theta, 7 over 25, and the given is in fourth quadrant. And we need to find tan 2 theta. Only one, since this one is a bit more difficult than the first one. So now, since it's cosine, we need to use the Pythagorean identity of cosine and sine to get the identity for tan, which is sine theta over cosine theta. That is one of the ways to get tangent. So first we need to find sine in order to complete tangent theta. So let's do that. So since we know our cosine is 7 over 25, we can input that into the Pythagorean identity of cosine and sine using sine squared theta plus cosine squared theta equals 1. So since we have a given cosine already, we just have to input it here. So it will be sine squared theta plus this given, which is 7 over 25 theta equals 1. So as we solve it, let's simplify the given. So square root of 7 is 49 over square root of 25 is 625 equals 1. So since we're trying to find sine squared theta, we just need to solve it. So let's move up over here so we don't have any more space. We need to transpose, or at least transfer. You need to transfer this to the other side to get the value of sine squared theta. So it will be 1 minus 49 over 625. And as we input that on our calculator, 49 over 625, it will become sine squared theta is equals to 575 or 576 rather over 625. Since this is squared, and as we see in this one, we need it to be just sine, so no square, so we have to square root this. So let's square root both sides. To cancel this will be sine theta, and the square root of it will be 24 over 25. But since we know that cosine is in the fourth quadrant, since it is given, our sine needs to be negative. So it will be negative 24 over 25. So since we have the value of sine and cosine, we are able to get the value of tan theta, which will be sine theta over cosine theta. Let's just transfer or input our givens, which will be sine, our given here, 24 over 25 all over cosine, which is the given. As previously mentioned, will be like this. And let's move over to the next paper since it doesn't fit. As we solve for the value, or rather simplify our given, which will become negative 24 over 25 times 25 over 7. We cancel these out. It will become negative 24 over 7. So our tangent, theta, is negative 24 over 7. So since we know the value of our tangent, we are able to input it to our identity, the double angle identity. It will be tangent to theta is equals to 2 tan theta all over 1 minus tan squared theta. So let us input, or rather substitute, our given that we found to the formula. So it will be tan 2 theta is equals to 2, the value of our tan, which is negative 24 over 7, all over 1 minus the squared of this. So it will be negative 24 over 7 tan. So ayan na siya. Then let's move over to the other side. Let us simplify each. So the top part, when simplified, it will become negative 48 over 7, and the denominator, after squaring and minusing, will become negative 50 or 527 over 49. So now let us just simplify the whole fraction. As we do this, 48 over 7 times 49 over, this is negative, so 527. Since both of them are negative, we know that our answer will be positive. So our tan to theta will be positive. So we just have to multiply these and will become 2352 all over 3689. And when we input it in the calculator to double check if there is no like lowest term, our final answer simplified will become 336527. So that will be our final answer for our other example. Here, this is the final answer when solved. This is the simplified, the lowest term answer. So this will be our final answer. So yeah, that will be the last example for our discussion about tangent or tangent double angle identity. I hope you learned something good about it. Thank you so much.
Simplifying trigonometric equation is significant because it helps us solve trigonometric equation and prove trigonometric identities. We may accomplish this by using basic trigonometric ratios, combined and doubled angle formulas, reciprocal and other identities, and expressing it in terms of a quick and simple function. In summary, double angle identities are an important aspect of problem solving because they reduce intricate trigonometric expressions. Their primary goal is to assist the solution of an equation and have broad application in domains such as physics, engineering, and mathematics. They are essential tools for both practical and applied trigonometric problems. And with that, concludes our short discussion for double angle identity. We hope that you learned something from our group. Once again, we are Group 3 from Blessed Gabriela.